All right, last part of transformations. Let's talk about stretching and shrinking our graphs. All right, so vertical stretching or shrinking. All right, so what are we doing? All right, this is where we are stretching or shrinking our y values. All right, and so what we're going to do is we're going to stick a coefficient out in front of our function. All right, and again, all that means is since it's outside of the actual function, we are just multiplying every y coordinate by this a. All right, so what makes it stretch or shrink depends on the size of a. All right, if a is greater than 1, then our y's are getting bigger faster. And so it's a vertical stretch. Our function is increasing faster or decreasing faster. If a is between 0 and 1, so it's a fraction between 0 and 1, then it's a vertical shrinking. All right, and what it really looks like is our graph kind of opens up. All right, and we'll see that with an example here. So you can see, all right, here is our basic parabola, good old y equals x squared. All right, if I stick an 8 in front of my x squared, then my y values get multiplied by 8. So the point 1, 1 now becomes 1, 8. Okay, and the point 2, 4, which is like way up here, now becomes 232. And so you can see that our graph here, right here, multiplied by 8 is growing faster. It's stretching. All right, so what about if we add a coefficient of 1 over 8 in front of the x squared? Well, now every y value gets divided by 8. And so, again, our original point here, 1, 1, now becomes 1, 1/8. Okay, our original point 2, 4 now becomes 2, 1/2. All right, and so you can see here that our graph has shrunk or opened up. All right, and you can see it again over here with these graphs at what 2 versus 1/2 does to some arbitrary function. All right, what about horizontal stretching or shrinking? All right, this is where we are dividing our x's by some a. So let me grab my pen again. So if I stick an a, meaning some coefficient in front of the x, what's happening? Well, what's happening is I'm dividing my x's by this a. All right, and so if a is between 0 and 1, meaning it's a fraction, then we get a horizontal stretching. So note here it's opposite to vertical. Okay? Similarly, if a is bigger than 1, then what I'm going to get is a horizontal shrinking. And again, guys, the best way to think about this is with pictures. So I've given you a couple pictures here. We'll start here on the left. All right, and so green is our original function. All right, if I stick a 1/2 next to my x, all right, what that's doing, all right, so if I stick a 1/2 next to my x, then all my x coordinates are getting divided by 1/2, which multiplying by the reciprocal says my x's are getting multiplied by 2, which is stretching my graph. It's making it wider. Whereas with the blue function, my x's are getting divided by 2. All right, and so my x's are getting halved. And so what it is it's a stretching, it's actually a horizontal shrinking or a vertical stretching. All right, and so this blue graph is going up faster. All right, again, a vertical stretching is a horizontal shrinking and vice versa. And we can see the same thing over here where when we multiply our x by 1/3, we're going to get a horizontal stretching. All right, it gets wider. All right, whereas if I multiply my x's by 3 with the blue function, I'm getting a horizontal shrinking. All right, let's look at one more example here with the good old absolute value, our basic v. All right, and let's compare what multiplying by 2 versus what multiplying by 1/2 does to the function. All right, and so we can see here with the table, all right, that when we multiply by 2, our our range values get doubled. Whereas when we multiply by 1/2, our range values get halved. All right, and we can see that here in the picture where we have our black basic absolute value function. And then when we double our function, we double our range values. And so we have this blue V that it's smaller, it's narrower, it's going up faster. Whereas if we have our range values, like we see here in the red, then our absolute value opens up. And we have our range values are halved. All right, and then what I want to include here at the end is just a summary of transformations. So this just shows you, again, what translating up and down or shifting up and down looks like, what shifting left and right looks like in terms of our function, as well as what vertical and horizontal stretching and shrinking, as well as reflections look like. So this is just, again, these two slides, this one and this one, are just a summary for you guys as you prepare for the second exam.